Hi, my name is Patrícia Spinelli, and I will talk about the power of astronomy museums. So here is the outline of my talk. I will start with an introduction of what a museum and science museum is, how education happens in these institutions. Then I will give you some examples of astronomy museums across the world and show some common ground between astronomy education and museum education. But first, who am I and where I work? I have a science background and I hold a PhD in astronomy. In 2008, 8 and 9, I co-created the Galileo Mobile project for the celebrations of the International Year of Astronomy with some colleagues and friends. And the experience of getting in touch with Latin American kids and learning traditional knowledge from the local elders had a profound impact on me, shaping my life in unexpected ways. And since then, I have never stopped working with the public. Nowadays, I am the public astronomer of the Museum of Astronomy and Related Sciences in Rio. And I also am a researcher in the field of science communication and education. And the Museum of Astronomy and Related Sciences, MAST in its Portuguese acronym, is originally the home for the National Observatory. It's a research institution under the Brazilian Ministry of Science and Technology. It's public and free to visit. And in addition to its public outreach efforts, MAST also conducts research and support the training of students and educators. Our research fields concentrate in history of science, museum and archive studies, communication, and education in informal settings. We are located in this beautiful building where we host exhibitions. Some of the old refractors are used for public observation, and we conduct activities and events with a wide public. So let's talk about a little about museums. So according to the International Council of Museums, these are not-for-profit institutions that collect and conserve all possible kinds of heritage. They should be opened to the public. They must communicate about their collections, and by doing so, they will be places for education experiences, enjoyment, reflection, and knowledge sharing. And its origins can be traced back to the cabinets of curiosity during the Renaissance and Baroque periods, that is to say, between the 16th to the 18th centuries. The aristocrats of that era engaged in the practice of collecting objects that could showcase their wealth, taste, and knowledge. And these collections found their places in dedicated chambers and rooms. According to some scholars, for instance, Podgorny, 2008, the deliberate arrangement of objects aimed at creating a pathway to understand a larger narrative of the objects and highlight the differences between them is a unique phenomenon in European history. So this practice gradually paved the way for the creation of museums and early natural museums. So the aristocrats actually accumulated a wide range of objects, including not only arts and crafts, but also natural specimens, fossils, minerals, dissected animals from exotic places, ethnographic objects, and more. So it kind of can be asserted that the earliest science museums, or first generation, began taking shape during the 18th and 19th centuries as natural history museums, showcasing collections of this nature to the public. For instance, the Wagner Free Institute in Philadelphia, established in 1850s, continues to house Victorian cabinets of mounted specimens organized by classification. Therefore, the collection and the systematic arrangement of objects are defining features of what a science museum of first generation is. The second generation of a science museums dates back to the early 20th century, and they placed a greater emphasis on the use of technology for educational purposes. So what distinguishes these museums from the first generation ones is the fundamental shift in the purpose of objects on display, from passive contemplation to active engagement for understanding. And a noteworthy example of such a museum is the Deutsches Museum in Munich. A vivid example of the third generation of science museums, are also called as Science Center, is the Exploratorium in San Francisco, California, which has set new standard for science centers globally, inspiring many others to adopt a similar approach and, more than this, advance science education through interactive experiences. Thus, it becomes clear that education takes on a different dimension in the realm of science museums. Unlike many other types of museums, science museums and centers prioritize education to a remarkable extent. But according to Hopper Greenhill and many other scholars on the subject, the context for learning in museums is not the same as in schools or in other sites for formal education, because according to Falk, museum going is about free choice learning, and free choice learning in museums is about identity formation and maintenance. And with this in mind, we can formulate the foundations of museum education that, according to the Brazilian museum education policy, is an educational process centered on the individual and their interaction with society, which values their ways of creating and living culture, politics, and history. Museum education exhibits three unique characteristics. First, there is the time that has two facets. Firstly, it concerns the amount of time visitors spend in museums. That is normally 2 hours. Secondly, it also encompasses historical time, because museums allow the visitors to explore the past, present, and sometimes even the future. Then there is the space, because museum buildings are often very opulent, and this enhances the overall visitor experiences. In addition, the exhibit designs contributes to aesthetic encounters, while visitors also have the freedom to select what they wish to explore, aligning with their individual interests. And then there are the objects, because they are central to museums' identities and mission, and objects act as tangible links to the past and convey the stories and knowledge that museums want to communicate. And these aspects collectively contribute to making museum education a dynamic and influential force in promoting lifelong learning, inspiring curiosity, and fostering a deeper understanding of the world in its many facets. But as a researcher and a museum educator, I would also like to introduce another dimension of museum education, that is the audience. Museum visitors driven by free choice form a diverse group varying in age, objectives, and familiarity with the subjects that museum may approach. So now I'm going to give you some examples of public astronomy observatories and astronomy museums across the world. In 2017, I conducted a study with a student of mine to gather insights from these institutions worldwide regarding their utilization of historically valuable telescopes for public observations. We extended invitations to members of the IAU, which entailed responding to a questionnaire made available over a 3-month period. And the responses we received not only allowed us to pinpoint the geographical distribution of these institutions, but also provide valuable information about their practices and experiences. 70 institutions confirmed to be carrying out public observation of the night sky with instruments considered of historical value. The map here illustrates the distribution of these institutions with a notable concentration in the global north. The majority of these institutions function as departments or sectors within universities, and only 11% of them indicated that they are also officially recognized as museums. This recognition designates them as heritage sites within their respective countries, denoting their historical, cultural, or architectural significance. And such designation often comes with legal protections to preserve their heritage value. So let me show you some examples of astronomy museums worldwide. So here there is the Royal Observatory in Greenwich, which is known for its historic significance in astronomy and navigation. It includes the Prime Meridian line and houses an extensive collection of astronomical instruments. It promotes night sky observation with the 28-inch rub refractor, the largest historic refractor in the UK and the 7th largest in the world. Then there is also the Cincinnati Observatory, one of the oldest public observatories in the US. It has a historic significance in the USA Weather Services and houses historical telescope, including the famous 11-inch Mears and Muller refractor, which is believed to be one of the oldest continuously used telescope in the world. And then there is the Sydney Observatory that similarly plays a seminal role in the history of timekeeping and meteorology in astronomy in Australia. They use a 29-centimeter refractor on German equatorial mount installed in 1874 and that is still used for public viewing. And two noteworthy examples in Brazil are the Museum of Astronomy and Related Sciences, where I work, where a centenary 21-centimeter refractor is also used for public viewing. And another example is the Astronomical Observatory of University of Rio Grande do Sul, with historical ties to the School of Engineering in Porto Alegre. So they still also use the old refractor for public viewing. And now I then would like to leave you with some statements from astronomers and other professionals who work at some of the sites found in our survey. They may offer you their perspectives on the power and impact that observing experiences with heritage telescopes have on the audience. So, for instance, although we try to avoid it, sometimes we look at the same target through the Great Equatorial Telescope. And as we do through small modern telescopes, and we have had comments on how looking through the historic instrument has a different feel. Many visitors are fascinated by its historic origins. The old refractor elicits wow moments from all who see and or use the telescope. There is a psychological impact to looking through the same piece of glass as a famous people of the past. An instrument from before things like the Civil War, the Wild West, or the immigration of many visitors' family. It's also hard to envision a replica that actually reproduces some of the effects of the 19th century glass. All visitors admire the possibility of observing the universe through the telescope. And now let's delve into a collective discourse compiled from various testimonies of masked visitors who have experienced observing with our old refractor. The environment makes a difference. That thing of entering a dark room, seeing almost nothing, climbing the ladder and reaching the refractor, where the only light is the one that is coming out of that little hole that you will observe. It has something so imposing that impressed me by size, and yet it's 100 years old. It's very exclusive and all, but at the same time, it's well preserved and has a great quality. It looks like a bit magical. It seems like I am a real observer, like a scientist. I felt like an astronomer. Creates that feeling of wow, I was delighted. So from the testimony of masked visitors, some key points can be concluded. The atmosphere and environment is very valued, and the use of real artifact of science connects people to astronomy. The combination of its age and exclusivity creates a sense of wonder. And now that we have already spent some time trying to show you how education in museums is so powerful, I'd like to use the last minutes of my talk to convince you that astronomy education / communication has many common aspects with museum education. Practitioners in astronomy education / communication understand that its impact extends far beyond the realm of the science and technology. Recognized as one of the oldest sciences, astronomy's roots lie in the observation of celestial objects, guiding timekeeping and practicing and predicting seasons across diverse cultures. It serves as backdrop for creation stories that impart moral and cultural precepts to younger generation in many cultures with oral tradition. Therefore, astronomy encompasses historical and cultural dimension. Prompting contemplation about our place in the universe also introduces the philosophical dimension. And on the other opposite of the spectrum, the allure of astronomy is not solely intellectual. Many people are drawn to it for the sheer beauty experienced during stargazing. So to finish, I also would like to talk a little bit about Girls in the Museum of Astronomy project as a transcending boundary of traditional education example. The project's primary objective is to involve girls in science through ongoing informal education actions under the context of science clubs. And within this initiative, participants carry on a small research project under the guidance of museum scientists and educators, and also science club leading teachers, fostering a dynamic and collaborative learning environment. Our pioneering pedagogical strategy intricately connects the three fundamental dimensions of museums, time, space, and objects, with the richness of astronomy education encompassing all its dimensions. Last year, our participants delved into the study of the light pollution, and following a 3-month period in basic astronomy topics, They were divided into 4 groups to conduct research projects. So they study light pollution and its impact on astronomy, investigating the effects of light pollution on astronomical observations, with a connection to the history of the National Observatory that eventually was deactivated to become a museum. Another group studied light pollution and heritage. They conducted interview with their grandmothers to gather stories about the sky, realized that people have the right to the landscape and that we are connected to the sky because the sky is part of nature. Another group studied light pollution and the sea turtles. They explored the impact of artificial light on the nesting of sea turtles. They interviewed a marine biologist to identify areas in Rio where sea turtles nest and how these areas are affected. In the last group, a group studied the dark sky potential dark sky parks in the state of Rio de Janeiro. They measured surface brightness of state of Rio sky and correlated with areas protected by its flora and fauna. They proposed a list of potential candidates to become dark sky parks, contributing to the preservation of natural darkness for astronomical observations. And they actively participated in 2 science competitions, including fairs and Olympiads, and emerged victorious in both. So this is Gabriela and the science teacher Giselle. And winning both competitions not only represented a remarkable achievement, but also stands as a testament to their dedication and deeper involvement with the topic of astronomy, but also the success of the pedagogical strategy that we employed. So this brings me to my last slide. I try to conduct a journey through astronomy museums, showing that they surpass the boundaries of traditional education, extending into the realms of culture, history, and our collective heritage. I showed some impactful projects and activities undertaken in these institutions with a broad audience. They serve not only as repositories for the wonders of the universe, but also as a catalyst for exploration, inspiration, and transformative learning. These spaces represent a convergence of the past with the future, where science intersects with culture, and the power of the education assumes a cosmic dimension. But I cannot emphasize enough that many of the important dimensions that museums hold are common dimensions in astronomy education. That is to say that our astronomy education initiatives can learn from museum education and take advantage of the non-science aspects to engage with various audiences. Thank you very much for this opportunity of talking to you.